Imagination. For those of you who have not heard of us, you'll hear a lot more about us, but we are a leading IP company. We produce IP that is used in graphics, compute, and AI at the edge. We sell our GPUs, our CPUs, our AI accelerators in a range of markets, in desktop, and actually even some of those cards go into the edge of data centers. We sell in mobile, we sell in consumer, and the particular focus of today, we have a very strong presence in the automotive market. Now, the automotive market is really working for semiconductors. It has been for a few years now, and we think it will for a number of years to come. Tremendous growth. You can see in this data from S&P, tremendous growth, and that growth being driven by the kind of digital cockpit and the infotainment systems in the center of the car, and also that very, very strongly growing ADAS segment, both of which really need great GPUs. So why is semiconductor looking so good in the car? Why are they consuming more and more of the chips we love to help make? Well, it's for several reasons. They're looking for performance. If you look in the car, we used to have tiny microcontrollers. We're now seeing much more sophisticated systems in zonal controllers and really quite large compute systems going into centralized compute. We're seeing a lot more glass. There's a lot more screens in the car. Go back 10 years, you maybe had a little car radio and some dials. Now you go in, fantastic e-cockpit, head-up displays, big central unit, and in some cars you've got kind of wall-to-wall, pillar-to-pillar glass. Every single screen needs a GPU. Those GPUs are getting more and more kind of sophisticated, driving more and more sophisticated experience, and that's what's selling the car. They want to go in and have a really great experience driven on those screens, driven electronically by those GPUs. And then the other thing that's coming into that automotive industry is safety. It's a good thing that safety's a big and important thing in automotive. I wouldn't get in a car without it, but it's really tricky to do well, and it's really important to do well for any IP going into a vehicle. We at Imagination are very set up to do this safety. We follow the ISO 26262 standards with their ASIL B and ASIL D qualifications for automotive. So a lot driving semiconductors, a lot driving that uptick in the vehicle. Now, we're a leading GPU supplier, and we're a leading GPU supplier in automotive. We have shipped more than 13 billion GPUs in 13 billion devices across all the markets. We've shipped nearly 400 million devices in automotive, and we are the #1 GPU IP provider for cockpit and infotainment today. It is almost guaranteed that you have had your life improved by an Imagination GPU at some point, either on a phone, on a TV, or in your vehicle. Now, it's not just us saying this. Our colleague is here with us today, Anshul, from More Insights, confirms that Imagination is a leading provider of GPU IP into automotive. The demand for pixel processing in cars has grown enormously over the last decade, with digital cockpit, dashboard, wide displays, and rear entertainment screens offering a smartphone-like visual experience. Imagination's combination of great performance for 3D graphics, flexible multitasking, and robust approach to safety has seen its popularity explode. So independent confirmation of the value and the importance of Imagination to the automotive industry. Now, why? Why is it that Imagination gets such traction with this important and growing industry? Well, it's really down to our GPU architecture, the flexibility, the safety, and the scalability that it brings to those automotive customers. So flexible IP. You put one of our GPUs in your car, you get to run compute workloads for ADAS, you get to run graphics workloads on the same device. We have comprehensive virtualization deep down in the hardware layer. So when you run multiple workloads on the GPU, you can keep them separated, you can control how they run, the priorities with which they run. We have an architecture that scales from the pretty small to the really very, very large. So if you're buying into our GPU for your semiconductor and you want to service a full range of vehicles, which you obviously do, you can have GPUs from us that will service from the very low-end automotive ranges up to the absolutely premium vehicles. Same GPU style, same software, same approach, scalable for your developers, scalable for your company. We have a very strong approach to functional safety. It's built into all our processes. We develop these things. We have a very strong developer experience, support for all the good APIs for long terms. We have a lot of tools that help people get great performance out of our GPUs. And we have a lot of long-standing partnerships with key automotive suppliers today. You know, you buy into the Imagination family, you're not buying into a risk or something new, you're buying something that's true and tested and has been supporting this industry for a number of years. So all roads really lead to Imagination. All roads lead to the Imagination GPU in automotive, and all roads lead to our new GPU, the Imagination DXS. Now this DXS core is really tremendously exciting. It provides us with safety without compromise. We have a new approach to providing ASIL-B with a distributed safety mechanism that allows us to give ASIL-B quality safety without the compromise on area, without the compromise on performance. And I'll talk about that in subsequent slides. This is a game-changing innovation for the industry. It's a graphics powerhouse. It has 50% more peak performance than our previous automotive core. It has the latest architectural and graphics features from our D series. Again, I'll talk about those in a few minutes. And it provides a tremendous visual experience that our automotive customers can use to build value, brand, and sell their vehicles. But it's not just that. This GPU is an absolute beast when it comes to compute. It is built for compute. We've co-optimized our hardware and our software to give us up to 10 times the GPU performance of our previous BXS cores. And that is really going to help enable and lift the industry in what it can do in compute in the vehicle. So let's take these in turn, have a little bit more understanding of really what we've brought to the industry and why we are so pleased and impressed with what our engineering teams have done with DXS. So we'll start with safety. Safety without compromise. So how do you do safety in a car? Today it's very simple. You run something, you run it again, and you check you got the same answer. That's basically what people do. Now, how do you do that? If you look on the left of this screen, you've got what you might think of a standard GPU core that you'd run a game on, not trying to do safety. It has a certain area, it has a certain performance. One thing you can do is you put two down. We call this dual core lockstep. You put two GPUs down. You run the workload through first one, the workload through the second, check you get the same answer. That'll get you the safety, that will get you ASIL-B certification, but it costs you twice the area. And these GPUs can be 20, 30, 40% of the silicon. So putting two down is a very difficult thing for an automotive supplier to do. The other way you can do it is you can take your GPU and you can run the same workload twice through it, one after another. And again, check you get the same answer. Sure, you're not spending the area, but you've halved your performance. So today, whichever way you cut it, your performance per unit area is halved when you have to do the safety use case. And remember, safety is really important in cars. With the new Imagination DXS core, we are able to achieve that safety use case with pretty much the same area and pretty much the same performance as a non-safety use case. That is a factor of 2 improvement in the performance density of this core versus another core for safety use cases. Now, a factor of 2 in this industry is huge. That normally takes generations to get to. That's what we're delivering with the DXS core. How do we do that? There's a dirty secret about GPUs. It turns out they're never fully utilized. There's always a little bit of some of the GPU somewhere that is waiting to be fed with something. So you never get 100% utilization. The other thing that's really great about a GPU is there's lots of blocks that look the same. So what we do is we look for blocks that are idle, short periods of time when they're not being fed. We pair them up, we call these safety pairs, and we run some test vectors through them and check we get the same answer. And we found we can do this across the GPU quickly enough to make sure we hit the coverage for ASIL B without compromising the utilization, without compromising performance, and not having to put twice the GPU down to do it. So we are able to achieve a guaranteed safe GPU to ASIL B standards without having to compromise area, without having to compromise performance. As I said, twice the performance per unit area as any other safety solution in the market. That's a huge improvement. And it's not just that. We take a very distributed view of safety in our cores. So we have the safety pair mechanism. We also have error correction codes, parity checks, watchdogs in there, dual core lock steps function. I won't read the list, but there's a huge number of things we've built into our GPU to make it safe, make it reliable, so that those automotive companies can stake their reputation on it. It's very, very important. So a very safe, very reliable GPU in DXS with twice the performance per unit area than anyone else can deliver for a safety use case. And it's a graphics powerhouse. Why? Well, if you go back to the previous automotive core, we had 2 processing units, what we call SPUs, scalable processing units. We had 2 processing units per core. In this GPU, we've gone to 3. So we have a 50% increase in the processing per core versus the previous generation. Now, where we were at a gigahertz was about 1 teraflops. 4 tops of INT8 and 32 gigapixels per second. That's what a core could deliver in the old generation. The 50% gets you to 1.5 teraflops, 6 tops INT8 and 48 gigapixels per second. Now we can put 4 down. We have a multi-core capability, enables us to put up to 4 of these down together. And we've also worked very carefully on the pipelining in the GPU. That allows us to get to 1.5 gigahertz, not just 1 gigahertz. If you put all that together, you're at a massive 9 teraflops of 32-bit floating point, 36 tops of INT8, and 288 gigapixels per second. Amazing, powerful GPU for compute and graphics. Now, I talked about that multi-core. This is really, really important for automotive because it really talks to the chiplet craze that's going through the industry. So if you think about 2 cores, one thing we can do with them is not let them talk to each other. And we can run one workload on one workload on another. It's great because we get isolation, freedom from interference, which automotive really likes. But we can also bridge the 2 cores together and treat them as a single GPU. So we get double the performance with a single GPU. Now, the important thing is that bridge, this little arrow here, between these 2 GPU cores is deliberately designed to be relatively low data rate. It's perfect for exposing across an external interface between 2 chiplets. So our multi-core solutions are very much set up and designed with this movement to chiplets in mind for the automotive industry. And we've added a huge number of features. All those features from the D series are present in this DXS GPU, giving us a fantastic GPU for all that rear seat entertainment. We've got 20% more performance density than our previous automotive core. And we include things like 2D dual rate texturing, really helps in post-processing across images. Pipeline data masters, which really helps with our setup and running of workloads on the GPU. A dedicated firmware processor, stops having to keep going back to the main CPU all the time. Fragment shading rate, which allows us to trade off in a fine-grained manner the kind of the graphics accuracy versus the the kind of fill rate we've got on the images, which allows you to have a nice trade. And we've got an HDR capability, the ASTC HDR, which allows us to have much better looking visuals on games. So 20% performance density improvement, and a whole range of features we're still bringing and innovating in graphics on this GPU, now available for the automotive industry. How does it compare? Really very well. So if you take a competitive automotive core and you take the Imagination DXS, we have 4 times the peak performance of our main competitor. If you look at how it performs, kind of performance efficiency against certain workloads, there are 2 types of workloads that really cause you problems in graphics. In one case, you're limited by the number of pixels you can push through the GPU. In the other case, you're limited by the amount of kind of compute you can do on each pixel going through. If it's pushing pixels through, fill rate, we find we are up to 2 times the performance efficiency. So frames per second per gigapixels per second, if you like. We're up to 2 times the performance efficiency of our competitor. If it's a compute-limited workload, we're up to 28% better than our competitor. And all these numbers are for non-safety use cases. You factor safety in, there's another factor of 2 because of that safety mechanism. So this is, very, very significantly better than anything else anyone can put in a chip on the market in terms of GPUs. Now let's talk a little bit about the compute intelligence. As I said, this is really designed with graphics and compute in mind. Compute is critical for automotive, it's critical for the GPU, and the GPU is becoming an ever more important compute engine for the cars. We actually sell GPUs into people making chips which never see a screen, and they're using it purely for compute. So what have we done? First of all, we've recognized, as the industry has recognized, that automotive really needs a GPU as part of their compute systems. It's parallel, it's very well suited to those AI workloads people are trying to put on the devices. It's very easy to develop. What the GPU is not is a kind of a fixed function special accelerator. There's a lot of people out there saying, look at my accelerator, it performs really well, and they're talking about silicon. You should go chat to the people who have the joy of trying to program it. They are not having a great time. And we're hearing increasingly that people in the industry are having to spend more and more software effort just trying to get the efficiency and the performance out of these dedicated accelerators. With a GPU, it's a known standard format, it's easy to develop for, it's got known APIs, it's got a mature ecosystem. So it's a very good target for developers, and developers are what wins this. It's very flexible. You can do compute and graphics on it. In that central compute situation, being able to run both workloads is critical. And it's very resilient. So what you don't want to do is just imagine for a moment what we're up against in the automotive industry. We make a GPU core as IP. We sell it to a semiconductor guy, maybe make a chip, maybe 2 years after we've designed this IP. They get into a car. Maybe it's 5 years before SOP on a car after we've designed the IP. How long does that car stay on the road? At least 10 years. And the automotive manufacturer wants to monetize that with updates throughout the course of its life. So you're looking at needing to have something which is going to be still current and usable for 15 years after it's designed. Now, you don't get that from very dedicated fixed function hardware, not with the pace that AI is moving. You need something flexible and programmable like the GPU. The GPU is perfect for the needs of the automotive industry. So what have we done to compute? Well, we've massively increased it. We started with the hardware. We added the extra pipeline. That gave us a 50% more compute performance. And we doubled the rate of the floating point 16. 16-bit floating point is really where machine learning is at. And we doubled that rate. So we have 3 times the raw compute power on this device from our previous generation. We make sure we support industry standard number formats and operations. So we've got 16-bit floating point, 32-bit floating point, int8, and dedicated support for int8 inner products, .8. So that makes it very flexible, very well targeted for many of the structures coming at the heart of these machine learning algorithms. And we gave it more memory. Memory close to compute is very important for good performance, and we did that in this GPU. So 3 times the raw performance. And then we thought about the software. And when we think about the software and imagination, we don't just think about the software sitting close to the GPU, we have to think of it top to bottom. So we start with the use cases, the computer vision use cases, the data pre-processing and post-processing use cases, and some of the more modern machine learning aspects. We take those and we map those onto a standard stack. We are very, very keen on open source and standards to allow the industry to actually innovate and develop. So we partner with One API, which is part of the UXL Foundation, trying to drive a new open, considered way of driving machine learning algorithms and compute algorithms down onto hardware. So One API is where we're at. We have the TensorGraph reference kit, we have a number of reference models, and we have our own performance analysis tools that allow a user to see how well their workload is running on target. And then we have dedicated libraries. So we don't want our customers to have to do lots of work to eke out the best performance. We do that job, and we supply a dedicated range of compute libraries, the BLAST linear algebra libraries that are needed. We've got neural network, deep neural network learning libraries that we provide. We've got dedicated fast Fourier transform libraries that we provide, all of which drive a really strong increased utilization on our GPU. So we aim at 80% utilization with these libraries for compute and bandwidth, and around 50% for some of the machine learning tasks. And that's pretty good in the industry. If you don't have this end-to-end approach, it's very easy to end up only getting 10, 20% utilization. So it's very important to think this through. Now, I talked about the UXL Foundation. I'm going to read it off here rather than here because my eyes don't work as well as they used to. So the UXL Foundation is critical. Software portability and the ability to take advantage of heterogeneous hardware is essential to the future of the automotive industry. We firmly believe that, with a GPU being a key part of that solution. The UXL Foundation is looking to provide a clear and easy path for developers to do this through the ongoing open source development of the One API standard. Imagination is a long-standing supporter of our ecosystem, and the compute software solutions they release today reinforce their commitment to building an optimal developer journey based on open standards. Imagination, we are wholeheartedly behind that. Open standards, flexibility, and the ability for the industry to actually develop without being constrained. They're too constrained today. So you bring all that together, and we get a massive, up to 10 times increase in compute performance. Now, given in this industry, people will normally sell their grandmother for about a 50% increase, a 10 times increase is incredible. And again, we've done that by considering not just hardware, not just software, but by co-optimizing them, top to bottom of the stack, all the way to the hardware. We've got the 50% increase from the SPU count. We've got the investment in software and those software libraries driving really strong utilization on the hardware. And we've got double the rate of floating point 16, gets us to that nearly 10 times increase in compute performance. Here's what you can do on a DXS GPU. That was a large language model running on our GPU. Some LiDAR processing working on the GPU. So I love that video. I love it because we talk about bits and bytes and teraflops. It feels a bit dry. But really, when you sit in the new vehicle, you go and buy a new car, one, it's the nice smell of new leather. The other thing everybody is drawn to is the look and feel. Those great dashes, those really slick UIs, the really slick presentation of all that lane control data, where the other vehicles are, critical. You know, it adds thousands of dollars to the value of a car. That is because of our GPU. And then the other side of it, the LiDAR processing, the image processing, the object processing, all of that is running on our GPU. That is the critical upsell that people are doing in cars today. You go buy a car and you want the options pack, they'll then charge you a lot more for all of the high-end ADAS features. It's all coming through the GPU. We add huge value to the automotive industry, all running on imagination. And the DXS with its safety use cases is a big step forward. So there we have it, bring it to a close. We're very, very proud of ourselves. We're very proud and pleased to announce to you our new Imagination DXS GPU. Incredible safety without compromise, with that doubling of the performance per unit area for safety use cases. An amazing graphics powerhouse with 50% peak performance and the latest D-series architectural efficiencies and graphics features, and an incredible compute intelligence platform. Hardware and software co-optimized for up to 10 times the GPU compute performance as we had in our previous series. Thank you very much for your time. We really appreciate it.